Now anybody that has access to a lathe and also engages in shooting air rifles is eventually going to make themselves a novelty airgun pellet. But I really didn't want to make just a novelty airgun pellet. It needs to have some sort of purpose, some kind of use. So what I'm intending to do is to make this thing in two pieces. It'll be a skirt, a tapered skirt with a head that will screw onto the tapered skirt and thus form the novelty pellet. The tapered skirt itself is going to be a measuring device for measuring the sizes of different targets. And being such a shape, it's going to involve a great many machining operations, which is why this video is so long. It's also going to be very hard to keep hold of. The more I machine off of it, the harder it's going to be to keep hold of it, to carry on working with it. So it took me a lot of thinking and planning as to what order I was going to make this in, chiefly driven by how I can keep hold of the thing for the next operation. The first piece is going to be the skirt. First thing to do will be to put a 6mm hole all the way through this. I'm going to be using that hole later on to hold on to it, so I do want to get it concentric. So use a centre drill first. And this is a 5.5mm drill. What I'm worried about here is drilling such a deep hole in aluminium. There's a risk that the swarf isn't going to come out of those flutes and it's going to weld and seize up in the hole. So there's a lot of pecking away at it and lubricating it with WD-40 as that goes in. And then use the cheapo 6mm cleaner. I'll lubricate that up good and proper as well, run it very slowly, and I'll just push that in by hand, just get it through and not give it a chance to seize in there. Satisfactorily, that will be a 6mm hole. Now the blue die-chem is really lovely stuff, but it takes forever to dry, upwards of 2 minutes or so. So that gets blown off nice and quick. And the odd leg calipers are useful for marking out the limit of the large taper that's going to go on that piece. Eventually I'm going to taper it down to that line. First feature to put on the end will be a 15mm spigot. I want it to be 15mm for a particular reason, and I want this spigot to be a good dimension and a good parallel cylinder, because as I go through this, that is one thing that I'll be able to keep hold of when I try to machine the other end of this piece. But that doesn't work out so well in the end anyway. We'll see that later. This feature is just about down to size, and I'm trying to clean up the shoulder. I've got it power feed on the cross feed, but it's really not taking any material off. So what I tried to do is disengage the power feed, but I don't know what I did, and I re-engaged the carriage feed, crashed the tool into the work. So that piece of work was ruined, had to do all that again. I want to put a 15-degree taper onto the part, so that's a 15-degree angle block on the compound slide, and stuck on there with a magnet and stroke it backwards and forwards with a dial indicator to get it set dead on 15 degrees for a 30-degree included taper. So with a combination of feeding the cross slide in and winding the compound slide backwards and forwards, I'll be able to cut that down to a cone shape. It's going to come all the way down to the far scribe line on the right there. It's got so many scribe lines on it as a result of crashing the work earlier on, but it gets through there in the end. There was still enough material to hold on to. That was the skirt of the pellet, pretty much shaped out on its exterior. This is a second part. This is the domed head of the pellet itself. I'm boring this out to something like 12mm with an end mill, just to remove the material initially to rough it out. Then I'm going to have to go in with a small boring tool to get that bore out to exactly 15mm, which is the diameter of the spigot I just machined on the other part. So those two parts need to fit together in that bore. One of the things I'm getting out of making this is an opportunity to use a lot of the tools that I've got. You only use tools occasionally if they're a bit specialized. So boring this out, I'm trying to use the telescoping gauges to properly measure the bore diameter inside there. So the telescoping gauge goes in, you set it to the diameter of the bore, whatever it is, and then measure that gauge on its outside using a micrometer. So I think I've got it pretty much to size, and here comes the other piece, which is initially a tight fit to go in, but both these surfaces are rawly machined, so as it goes in and out a few times, some of that smooths off and it becomes a much better fit. The back end of this domed head also needs a tapered bore as well, but only so deep as to accept the shoulder that's on the skirt. So I can't just bore that out to the taper that I want as deep as it will go. It's only got to go to a limited depth. And I want it to accept the rather complex shape of the skirt, but the surfaces that meet each other, the surfaces that touch and stop its travel, I want that to be the end of the skirt. So there's some red Sharpie on the end of that spigot on the skirt, and if that contacts the bore, then that's the contact face I want it to make. But once it's all screwed together, it should look like one solid part. Well, again, on the underside of the domed head, it's just a matter of bringing out the major taper to form the underside of the dome. And that taper's got to come out really until it meets the internal tapers that I've already put on the underside of the head. This part is really quite shallow, but I want the threaded hole inside it to have as much thread as I can reasonably make. So that's actually an old worn out M6 tap. It broke some teeth off the end of it, but didn't throw it away, ground it flat, put a very small chamfer on its lead and made myself a bottoming tap. That way I can get as much thread in there as the hole will accept. Doing it by hand, I can sense when the tap actually meets the bottom of the hole, then back it out again. I want to part that head off of the stock cleanly, but the parting tool is sticking out a very long way, and it's a very thin tool as well. I can't remember if I did this on power feed or not. I think I might have done, but it's a little bit nerve-wracking trying to slice through such a large piece of stock like that. Got as much coolant as I can get on it. It's blowing compressed air as well to keep it cool, keep everything flowing. But towards the end it started to jam up with the swolf jamming up against the tool holder. So I had to stop it before it fell off and just ease the part off by hand at the end. Now that I have one half of the device with a hole through it and the other piece of the device has a thread in it, I can fasten the two together. Need to fasten them together because I need to turn the whole assembly around, hold onto the base of the skirt, and then try and fashion the dome on the head. So that flat-ended dome there, that's got to be put into something like a 20mm radius, and I don't know how I'm going to do it at this point. So my first efforts are just to try and rough off as much material as possible by eye to get a general shape of what I need. And following that, I'm just going to try and use a very large tooth file to bring it down to approximate dome shape, get rid of those steps. It's a special file for aluminium, not an ordinary file that would get clogged up. But after a certain point it started to show some chatter marks and facets in the larger diameter of the dome, so that wasn't going to work. It wasn't going to work to a finished part anyway. So I resorted to this. Using pieces of tool steel, I fashioned up a tool rest, sharpened up a second piece of tool steel to make some kind of a cutting or shaving tool, and gently saw how this would go. Now this is normally the technique of the wood elf. If anybody has seen stuff fashioned on a wood lathe, this is how it's done. Using a rest close to the work and some kind of gouge or chisel that's long enough to control by hand, and you can feed it into the work and control how much you shave off. On the outside here there's a bit of chatter going on because it's already chattered, but with a bit of practice I was able to smooth that out and make it a bit more controllable. Constant checking by eye to keep the thing approximately round and the right size, and it worked out okay. But if you are going to do something like this, put some kind of handle on the end of the tool. Don't try and hold a piece of raw tool steel in your bare hands on a machine tool. Now that's a good proportion of the work done. I've parted off the bottom of the skirt turned it around, and it's now mounted into a ER32 collet on the 15mm spigot on the end. Now, it's the only cylindrical surface I've got left, and it's really short. I thought it might be enough to hold this part, but it turned out quite differently. As I'm cutting in the rear end of it to empty out that cavity, I'm going very, very slowly to begin with because the tool won't fit in the hole. But as the tool gets bigger, I start to be a bit more aggressive with it, which didn't work out. Now the camera is staring at the part all the time. You can see what's going wrong. It's coming loose in the collet. It's all out of line. But I'm looking at lots of different things. I'm looking at travel dials, indicators, all kinds of things. And when I'm looking at the part cutting, I'm looking at the tip of the tool, not necessarily the material around it. Now, this went on for quite some time. I realised something was going wrong, but didn't realise quickly enough that the part was coming out of the collet. And that was a result of too much stick out, not enough grip length, and taking too heavy a cuts. But the part wasn't ruined. I managed to get it remounted back in the collet, slowed everything down, took everything a lot more easily. And as I got deeper into the cavity, the effective stick out isn't so much. So I managed to get the part pretty much finished off in that kind of setup there. But I wanted to relieve all of that cavity to make it look a bit more realistic. Here we have the steel stud that's going to hold the whole thing together. So carefully down to 6mm to fit in the bore of the skirt. The end of the stud though, that's taken down to 5.8 to give the thread half a chance to cut. And while I would cut the thread by hand, I really couldn't resist powering the die off. It's just too hard to not take a chance on. Having made the stud, I could mount the skirt on the stud. At least I could if I used the right size washer. But there's one more feature to take out of the end of this, out of the end of the 15mm spigot. There needs to be a groove for an O-ring. The rubber O-ring is just going to provide some friction to stop the whole thing accidentally coming apart as it dangles from the clip or the belt or wherever I choose to dangle it from. So gentle light cuts again, just gradually teasing that groove big enough to take the O-ring that I have available. Parting off again, but this time it's cheap, horrible, don't know what it is, steel, and sometimes that's been harder to part off than the aluminium has. But with that amount of coolant blowing onto it, it's been a lot more successful than when I first started. Confident enough to actually try and grab hold of the part this time. but even so you can see the tool post jerking up and down as the parting tool is grabbing into the work. The lack of rigidity here is really coming from the dovetails on the top slide. The stud is going to need a hole in it for a key ring, so I can hang it from something. But a hole straight through a full round rod isn't going to allow me to put a small key ring through it. So bring that down with 2 flats. Just take 3mm off each side of the stud. Will give me a 4mm flat end that I can drill a hole through. Using the large centre drill to make that hole gives me a free chamfer on this side, and then just flip it over again, chamfer the other side. I really don't have any particular technique for this, but combination of old engine oil and a blow lamp and heating the part up, watching it carefully, dipping it in more oil and then letting it cool off, it sometimes results in a half decent bluing of the part, turning the part black. Let that cool off. I'm going to Loctite that stud in. It won't go anywhere as long as the whole assembly is screwed together, but don't want to be removing the head off of the skirt and then have the skirt fall off the stud. Pop that O-ring on to provide some measure of friction. Pass a coiled wire ring through the stud and it nice and dangles. I will spend many hours on a practice range shooting at targets in the wood. Now the purpose of the practice is to try and develop some skills, develop some techniques, and one of them would be on range finding. And in order to do that, I need sometimes to confirm the size of the target that I'm trying to shoot at and trying to guess the range. So if there's no one else on the range, I'll be lucky enough to be able to go out to the targets themselves and measure them. Now these targets have holes in them. You have to shoot through the hole. That one is 20mm because that's the diameter of the shoulder of the skirt. That one is 15mm. That's the diameter of the spigot. I've got some graduation markings on the skirt which would tell me the size of other targets. This one is at the longest range we shoot at, that is 35mm. And the last one that was close by, that meets up with the middle graduation line, so that is 25mm. So I no longer have to guess at something that bothers me when I'm trying to practice.